Hey there folks, we're going to learn how to use the Bambu Lab printers. Very first step is to go and visually inspect the printer bed to make sure it is clear. You're going to personally do that with your own eyeballs. You're not going to use the software because if you go to device and you click on this little play icon, this is what you might see. You cannot visually tell if this part has been removed from the print bed and if it's clear. If you send a print to this printer and there is a part on the bed, it's going to ruin everything. So you've got to go and check it physically, go check that it is clear. You also want to make sure you have the filament that you want loaded into the printer. So there are several printers that you can select that have different colors, different materials, and you need to decide what you're going to use. But the first step to loading a print is to go to the Prepare tab and to click on this little icon and select the STL files that you want. Remember to export your designs in CAD to STL, the STL format, so that you can import it here into the Bambu Lab Studio. I've loaded these two files in, and you notice they loaded overlapping each other. So the very first thing I'm going to do is arrange all objects with this little icon. You could also do it with this icon up here. It's the same thing. And it will arrange it very efficiently. It should work most of the time. The very next thing you're going to do is make sure that you have the optimal layer orientation. Something you should understand, even in the design phase, is that the weakest part of a 3D print is the Z direction, the direction that the plane that the print bed moves in, because the layer adhesion is the weakest part of a 3D print. You could pull and push on a 3D print in the X and Y direction, like pull it this way, this direction. But if you were to pull it apart in this direction, it would pull apart much easier. So you have to consider that when you're designing your part so that you can design something that can easily print, but that its weakness is covered in the design. So you don't have any weak features that are in the Z direction. I hope that makes sense. You'll understand that as you go and experience 3D printing for yourself. So make sure you rotate the parts so that they have the best layer orientation and so that they don't fail. You want to have a good contact with the print bed. If I rotated this because I wanted the best layer adhesion, let's say, I rotate it like that. I'm sorry, the best layer orientation for the best strength. Let's say it was like that, like this. The problem is that this little sliver is the only thing touching the print bed. So this would be a guaranteed failed print. So this would not be the best way to orient this, or it wouldn't be the best design for this part. I would need to go back and redesign that so it could be more easily printed. We're not going to get too much into supports. But let's go through all the settings that we might want to use for a 3D print. So the first one is layer height. 0.2 or 200 micron layer height. That is referring to every step down that the print bed makes for each layer. So each layer thickness is going to be 0.2 millimeters. So the very first layer, then the second, it's going to build layers that are 0.2 millimeters thick. 0.2 is a good balance of strength and resolution. So you notice how these little divots here for your fingers, this is like a cap that needs to be come on and off, but it's going to be a tight fit. So we put these little finger hole sort of grip places. These features are going to be built in the Z direction. The printer has very good resolution XY. It's got those stepper motors, and it's running very precisely, but it's got a 0.2 millimeter precision going up and down. Okay, so it's going to have a bit of a stair step resolution. if I wanted to improve that resolution, especially like for this part where I've got lots of little details in the in the Z direction, you know, I don't want a bunch of steps. I want this to be as smooth as possible. Then I want this to be a smaller layer height. Okay, but as I go smaller, or if I go too big, that means it's going to be, you're going to sacrifice strength. If we were to switch to a 0.6 nozzle, a 0.6 millimeter nozzle, we could go bigger than, let's say 0.25, but I think probably 0.25 is probably the max layer height you should use for a 0.4 nozzle. What's the next thing? Let's look at wall thickness. So your print is going to have at least 2 wall loops. That would be the bare minimum. And then if you want it to be a little bit stronger, you can thicken up the wall. Now we'll talk about why there are walls here right now. So you actually print a shell. There are walls, there are floors, and there are roofs. Now this calls it just top and bottom shell. This is making the box, and really that's all you need for strength. This is a box frame, and your strength is in the box itself. So this is why 3D prints often have an infill density. There's just a little, like a grid pattern that's printed in the space where the walls don't meet. So like maybe this part, it would be all wall. It would be completely filled because it's just too thin right here. But maybe this part right here would be a cavity where there would be this infill. And 25% is another good place to start. You probably don't need to go beyond 40% though. You start to, there isn't a lot of gain going past 40% infill. Okay, so so we talked about wall loops. You can make them a little stronger, having more wall, a thicker wall. Also the same thing for a thicker bottom and top, but there's a limit to how much infill density really helps. All right, the next thing we'll look at is supports. So if you've got an overhang, so let's say we rotate this part upside down. So now we've got that opening on the bottom. We've got this overhang is what it's called. And the printer can't just print that in the open air. If you imagine this print has all these walls constructed, and now all of a sudden it's got to print across the top here, and it's got nothing, no foundation to lay on, that's going to be a problem. It's going to be a messed up print. So what you need to do is enable support. So it will print some material here in the center and go up just barely up to that point where it's going to start going across the top, across the cantilever, or not the cantilever, but the overhang area, and the supports will help for a smoother print. So rafts are another idea. That's where you can lift up the print a little bit with some material underneath in case you have a situation like this where I've got a fillet on this side and a chamfer on this side, and so it's really just this little ridge, and that's really not enough to contact the print bed and make a good adhesion to the print bed, because what happens is the print can come loose from the print bed, and that's really not good. When your printer head is going really fast over it, it's going to put a little bit of force on the print on this part, and that could cause it to break away from the print bed, and that would be a failed print. So you could use a raft when you don't have enough contact with the print bed. So you could add a few layers of a raft. You could change what kind of filament you have for the raft. You can also change how far out your brim or your raft goes out. So there's several things you can do to help support your parts and keep them on the bed. So here are some skirt loops, so you can increase the number of skirts you have. There's some other features you can play with. We're not going to go over all of them, so we're just going to move on here to the next thing, which is changing the filament. So by default, I think whenever you import something, it's going to pick the very first filament in the printer. So if you want to change a filament, you can right click on the part, do change filament, and click on the part on the filament that you want. You could also select all of them by control clicking. You can do the same thing, select the filament you want, let's say basic. But there's also another way you could change filament, and that's called color painting. So what you want to do, like if with these letters, let's say I want them to have a different color. So I'm going to fill, select a different filament. I'm going to fill in these areas with a different color so that the letters will be, so they'll stand out. So this is a pretty cool thing you can do. I'm not going to go through the whole thing, but that's what you can basically do to change the color for text and other interesting features of your parts. So once you do all that, now we're ready to print. Once you have your layer orientation correct, you have your bed adhesion sorted out, you've got your supports enabled, you've checked your layer height and your wall thickness, all the things you need for your part, we're going to go to preview. And the first thing it's going to do is slice the parts, make sure that the G-code is going to work out, and we'll see if we have any errors here for this. All right, it says slice is okay. So we're going to X out of these. We can close that out. All right, so this is a generated thing by the printer because it needs to change what filament it's using. It's got to clear out the old filament and start up the new filament and then start printing and then switch over back over again. So this is self-generated here. But I'm noticing that my filament, my resolution on this part is not that good. So what I need to do is I need to go back to prepare and change the layer height to 0.1. And now we'll click preview again. And we'll see here. Any minute now. Okay, that looks a little bit better. I'm happy with that. So we'll click print plate. Again, we'll check to make sure we have the correct printer that we checked. We visually checked that it was okay. And we're going to deselect time lapse. We don't need that. And we'll click send so we can send it to the printer and it will start printing. And that's all you've got to do. Hope this helps.